First, we will demonstrate the various ways that both lower and upper joists and beams can be designed. Secondly, we will install and level a set of joists in a typical setup. Beams and joists are very much the same thing, and the term may be interchanged in some books. A beam is more often considered to be a heavier timber that will carry an intermediate point along the floor joist. This provides for larger clear span. A joist is a lighter timber with closer spacing. The loading of beams and joists is in two parts. One, the dead load. This is the weight of the material used. And two, the live load. This is the weight of the occupancy, people, furniture, or any other applied use. Most log buildings are started flat on the bottom, in such a manner that they could be set onto a flat platform or floor. In this case, the joists and beams are built into or on top of the foundation. Often the joists are placed on top of the concrete and extended to the outer edge. This is acceptable if the foundation is to be faced with rockwork. Otherwise, I would rather head the joist ends with a log. The next style of joist placement then is to place the joist on top of the concrete and then cut pockets into the first log. The joists do not need to extend all the way across the foundation wall, and give thought to which way the first half log is to run. If the logs are average size, 10 to 12 inch top, the half log might be on the side where the joist ends will be, example the long side, so that the end of the flooring might be notched into the side of the first full log. The next choice would be to use the first log as a beam, then seat the joists on top of this log. This style has two significant uses. One, the floor is raised to provide more headroom in a possibly low basement, and two, the first log or beam can rest on piling or posts when a basement is not needed. The required size and spacing of floor joists will depend on size and span. The vertical height of a beam is more important than the width, so two medium-sized logs placed one above the other may give better strength than one large log for a long span. The best size and spacing for both joists and beams can be calculated by use of a mathematical formula, or more conveniently extracted from engineering tables. From this table, we can see that a 12-inch mid-span diameter log with a load of 120 pounds per lineal foot can be expected to span 28.4 feet. Span tables may be obtained from the Log Builders Association. Most importantly, avoid creating stress raisers where joists are seated. This is a condition created by sharp angles on the underside of the timbers. Good planning and careful log selection can go a long way to avoiding this situation, but if such a cut is unavoidable, try to round out the corners to help relieve point stress. Upper floor joists are most frequently made of logs, and we'll deal with the selection and placement of these timbers. The suggestions detailed here may also apply to the lower floor joists. When the desired wall height has been reached, you will need to place the upper joists for a second floor or loft. This height will most often be 9 feet or 2.7 meters. The walls don't need to be exactly the same height, but of course the closer they are to the same height the better. Snap a level line at a known height above the base and at each end of the building where the joists will be resting. This line is to represent the foundation line and is simply a convenient place to take measurements from. You can measure right from the foundation if that is more convenient. Now mark off the centers for the joist locations, then place the selected joist material up on these positions. If there is to be a balcony or extension to one end, you may want to place the large end of the log in that direction. Place the large end of the joist or beam accurately on your mark, then block it with rolling dogs. Shift the other end into place and dog that end also. Roll the log until the very best straight side is up, then dog it securely with drive dogs, only at the large end. Do this same operation with each joist. Now you are going to scribe the joist down so that the tops of each will be the same height above your reference line. To do this, place a level across the large end of what you judge to be the smaller joist. Measure from the bottom of the level to the reference line. Let's say this turns out to be 650 millimeters. Go to the small end of the joist and wedge it up until this end is also 650 millimeters above the reference line. Because your joist is 300 millimeters in diameter, and you would like to scribe it down about halfway, then choose a scribe width of 150 millimeters. This will leave the top of the joist 500 millimeters above the reference line when it is completed. Measure the height of each of the other joists at the large end, then raise the small end of each joist to match. Subtract 500 millimeters from the measurement at each joist, and the remainder will be the required scribe height. So the scribe setting for each joist may be different, but the setting should be the same at each end of one joist. When all your joists have been positioned and the proper scribe setting noted on the joist itself, set up your scriber and execute a double scribe. A double scribe means to place 2 pencils in your dividers and draw the upper and lower lines at the same time. The details for this is to be found on tape number 5, Other Notches, Part 1. Remove the joists from the building to do the cutting, and if you have suitable equipment, remove also the log on which the joist will be resting. Doing the cuts on the ground will speed up the work and increase the accuracy, but these cuts can also realistically be done up on the building. Here we are using a modified square notch. The outside shoulder is sloped to avoid any possibility of the joist retaining water. For some applications, you may want to use a blind notch on the joist or beam if you don't want it to show on the outside of the wall. These same procedures can be used for beams. Lower floor joists that are log and are to rest on a concrete ledge or pocket will be treated a little differently. First, square the end of the joist so that they are each the specified width and height. This might be 8 inches or 200 millimeters. Block up the central beam so that it won't deflect under the weight of the joists. Place the joist across the beams at its proper location and wedge or block the ends of the joist up until they are equal. Set your scribers to the amount that the ends must come down to contact the seat. Then scribe the joist at the beam. A square notch would be the most appropriate choice for this location also. Experience has taught us that it's better to cut the flats on the top of the joists after they have been fitted to the building. Here the end logs have been reset on the ground for convenience. When all the joists are in place, you can snap a line across the ends. The line should be equal distant from the foundation at all points. Again, it is best to remove the log from the wall to do the cutting. If removal is out of the question, you might build a scaffold and roll the joist to that spot. Roll the log until the line on the end is vertical, then snap an ink line on the side. Be careful to snap the line in the direction of the cutting plane. Roll the log 180 degrees and snap a line on the other side. Cut away the slab and be sure not to go below the ink line. Then brush or plane the joist right to the line. Now is the time to cut saddle notch scarfs on the top of the joist to accept the cap log. The cap log will be notched over the ends of the floor joists and most often flattened to accept the roof structure. Use good, clean, straight logs for this position so that you can get a scribe line that is easy to see. The multiple notches in this log will test the skill that you will have developed as you built the walls. Work very hard to obtain the required fit on the first operation, because adjusting and refitting this log can become a little frustrating. If you have removed the top logs of the wall to the ground in order to fit and level the floor joist, take this opportunity to set, scribe, and cut the flat on the top of the cap logs. If your building is large and the cap log long and heavy, it may be a good idea to block the setup at the center to keep everything in line. Cutting the notches for this log is a satisfying experience. You may decide to use saddle notches, round notches, lock notches, or sheep's head notches. Any of these can be suitable, and whichever of these you choose, a benchmark in the project has been reached, and this nice symmetrical row of notches will confirm your ability. The joists are finished, but you will want to cut a seat in the cap log and plate logs for the side and end of the flooring. For the plate logs, these lines might be located and cut along with the joists. The recess on the cap log might be located from the top of the scribe line and completed on the ground after the notches are cut. If there is any suspicion that the cap log might have to be adjusted, it may be better to replace the cap log and complete the layout after the fit of the notches has been confirmed. Also, you will lay out the flat for the top of the cap log, and if you take the time to check the location of the center lines and square of the building, you can also cut the mortises for the roof structure while this log is on the ground. If you are using an outrigger plate, treat the top log of the wall as a joist and flatten it also. Alternately, the flooring can be notched into this log, then continued on the other side. It is also an option to space the joist wider and use them as beams. In this case, you would cut a wider recess at the plate log and cap log to accommodate dimensional joists and ceiling, as well as the flooring. A recess for the ceiling material can be dadoed into the edge of the beam or a furring strip secured to the top. If the ceiling is to be decked with a planking material such as 2x6 or 2x8 tongue and groove, it can be an advantage to make a groove for electrical wiring. If you are going to run additional joists, the wires can be run between these. Because these logs are handled several times each, it is recommended that you use slings to avoid excessive scarring of the logs. A soft grapple of a suitable size range will also provide this advantage for the whole building. Your floor joists are now all in good order and no additional work should be necessary. This is an occasion for a modest celebration. We can have a major celebration after the roof support system has been put in place.